Good afternoon, everyone. Today we will have a lecture on steel structures. So already in last lecture we have discussed about the connections. So we have seen about the bolted connection and welded connection in last lecture. So again in today's lecture we will have some more concepts regarding the connections. So we will start first with the bolted connections, and after that we will switch over to the welded connections, because these two, that is bolted and welded connections, are most commonly nowadays used. Rivet connections are not used as per IS, that is 800 2007. Rivet connections, they are not used, but welded and bolted connections are they are used in nowadays. Okay, therefore we will see about the welded connections and bolted connections. Okay, so in last lectures I have discussed about the basics regarding the welded connections and bolted connections. We have seen the different types of bolts also. Okay, so we have seen the bolt size, or different types of bolts also, the figure of bolt also, the parts, different parts of the bolts also. So in today's lectures we will switch over to the bolted connections. Okay, so this slide, or this that is figure, already I have discussed in previous lecture, but it in today's lectures, so it is totally dependent on this figure. Therefore we will discuss about the figure. In this figure we will discuss about the bolted connections. Okay, so here these two plates are there, in which there are 9 bolts are there. Okay, so in this 9 bolts we will first, this load, it has been applied on in x directions. This p load, that is the tensile force which has been acting on both sides of the plates. So here these two plates, this one plate and this second plate, it has been jointed with the help of this 9 bolts. This circular part is nothing but the 9 bolts. So there is one plate which has been overlapped with the other plate. Just you have to imagine this two concepts. So this one plate, it has been overlapped with the other plate, and it has been jointed with the 9 bolts. Okay, so what are the different criterias, or what are the different basics regarding this connections, we have to see. So when we are discussing about the pitch value, what is the pitch value here? These are the loads, it has been divided, or the load, it has been taken care in tensile force in x direction. If the distance, it has been measured along the direction of force, if the distance, it has been measured along the direction of force, that means this distance between the two bolts, when it has been measured along the direction of this force, a tensile force, such value, or such it has been called as the pitch values. Okay, so pitch value is nothing but the distance between the two bolts when it has been measured along the direction of tensile force. Okay, when it has been measured perpendicular to the direction of tensile force, then it is called as the gauge distance. Then it has been called as the gauge distance. Okay, when it has been measured perpendicular to the direction of this tensile force is horizontal, but the distance we are measuring along the y directions, that is perpendicular to these directions, then we will call this as the gauge distance. These are the some that is the basics, these are the some nomenclatures. These are the basics regarding these words are frequently used in designing. Find out the pitch value, or find out the gauge distance, or what is pitch value or gauge distance. So gauge distance is nothing but the distance which has been measured along perpendicular to the direction of this force. This is nothing but the gauge distance. Again, same way, what is end distance? End distance is the distance from the outer surface of the plate to the outer bolt. Okay, outer surface of the plate to the outer bolt, when it is measured along the direction of force. Okay, here force is in x directions, and we are measuring from the outer surface of the one plate outer surface of the plate to the outer bolt. So this distance is called as the end distance. Okay, when again this distance, it has been measured perpendicular, when the distance which has been measured from the outer surface of the plate to the outer of bolt, but it should be measured perpendicular to the direction of this force, because force is in x and we are measuring in y directions. So this distance is called as the edge distance. This distance is called as the edge distance. Okay, so as per IS, that is 800 2007, in clause number 10.1, 2.2, 10.2.2. What is the minimum pitch value? It has been mentioned in IS 800 2007 10.2.2. So in page number 73 and 74, it has been given the criteria. It has been given in clause number 10.2.2. The minimum pitch value as per IS 800 2007. What is the minimum pitch value? It is 2.5 times the diameter of bolt. 2.5 times the diameter of bolt. What is the minimum pitch value as per IS 800 2007, which has been mentioned in page number 73 of clause number 10.2.2? That has been given as 2.5 times the diameter of bolt. What is the maximum pitch value? So here maximum pitch value, we will take this as maximum pitch value. Again, it has been mentioned in the clause number 10.2.3 of the same page number 73. What is the maximum pitch value for the tensile members when the member are in tensions? So the maximum pitch value, P stands for pitch. Pitch should be, it should be that is 16 times the diameter. Okay, this value 16 times the diameter, it should be greater than pitch. Okay, the pitch value should be 16 times the T is nothing but the thickness, 16 times the T, or 200 in tension members, and 12 times T stands for the thickness, or 200 in compression members. So this is nothing but the maximum pitch value. If there are adjacent plates are there, consecutive plates are there, so these are the tension and compression members. If there are adjacent plates are there, so what is the maximum pitch value? So P stands for pitch. So it is taken as, it should be greater than 32 times T stands for the thickness of the plate, or 300 mm. What is the minimum edge distance? I've already discussed what is edge distance. So edge distance is nothing but, this is nothing but the edge distance. Okay, this edge. So what should be the minimum edge distance? So the minimum edge distance in this case, it should be again mentioned in clause number 10.2.4.2 and 10.2.4.3. It has been given as minimum and maximum distance. Okay. So in what is the minimum edge distance? It should be greater than 1.7 times diameter of hole. H stands for hole. Diameter of hole, DH, diameter of hole. So it should be 1.7 times diameter of hole, minimum edge distance, or it should be 1.5 times diameter of hole for tension and compression members. Okay. Again, what is the maximum edge distance? It should be less than 12 T epsilon, 12 T epsilon, 12 T epsilon. So epsilon is nothing but 250 divided by Fi raised to 1 by 2. So 12 T, T stands for the thickness. Okay. So these are the values. With the help of this edge distance, with the help of this pitch distance or end distances, we have to calculate, or we have to find out the distance. Okay. So depending upon the design criteria, we have to find out the different things depending upon this pitch value or edge distance or end distance. Okay. So again, I have discussed in previous lecture what is bolt value. Bolt, we have to find out the bolt value. Bolt value is nothing but the strength of bolt. In short, what is bolt value? Bolt value is nothing but the strength of the bolt. Okay. So strength of the bolt, we have to find out the strength of bolts because we are connecting the two plates with the help of bolts. Okay. So in order to while connecting the two plates with the help of bolts, the strength of the bolt should be more, so that the load carrying capacity of that plates or load carrying capacity of the bolts, it should be more, so that it should be safe, and it should not be fracture, or it should not be, there should not be a fracture or cracks in the plates as well as bolt. Okay. So such increase in strength is nothing but the bolt value. So what is the bolt value? It is the design load carrying capacity. Yes, it is nothing but the strength of bolt, or in simple words, it is nothing but the load carrying capacity of a single bolt, one bolt. So it is calculated as a minimum of design strength of bolt in shear and bearing. Okay. So it should be minimum of minimum of shear and bearings. It means design strength of bolt in shear and bearing. That means while finding out the bolt value, we have to first find out the shear value and then bearing value and tension also. Okay. So while finding out the bolt value, we have to find out these two things. It is very important. Okay. We have to find out this bolt value, this we have to find out the shear value, this is and we have to find out the, that is the bearing value of the plate as well as bolts. Okay. So first we have to find out the shear value, and then we have to find out the bearing value. Okay. So these are mentioned, or it has been given in the IS codes. Okay. While finding out the bolt value, we have to find out the shear and bearings of the plates or strength of the bolts. So these are mentioned in IS code. I will show you IS codes also. Again, what are the properties of bolt materials? So we have to find out the yield stress, that is grade of bolt, yield stress and ultimate tensile stress. Okay, so yield stress and ultimate tensile stress, it has been mentioned in IS codes. Okay, so normally we are using tensile stress. So if it is not given, then we have to find out, or we have to take this tensile stress, ultimate tensile stress, depending upon the grade of bolts. You have already you have already seen in concrete technology also, there are different grades of cement. Okay, the grades of steel. Similarly, the grade of the steel materials which we are using. Okay, so these are the different grades of steel: 4.6, 4.8, 5.6, and 5.8. So these are the grades of bolts. Grades of bolt. Grade of bolt is 4.6, 4.8, 5.6, and 5.8. So these are the in increasing way. In other sense, these are the, depending upon these grades, the ultimate tensile stress is dependent. For 4.6, what is the ultimate tensile strength? FUB, it is 400 megapascal, that is Newton per mm square. For 4.8 grade of bolt, it is 420. For 5.6 grade of bolt, it is 500 ultimate tensile stress. For 5.8, it is 520 megapascal pascals Newton per mm square. So no need to confuse, or there is no need to. That is uh, we have to take, yeah, these parts, or these tensile strength, we will take directly from the IS code. So I am switching over to the IS code. So this IS code, that is nothing but the page number. First we will see about the page number 13, then we will have this 13. So we will switch over to the page number 13. Yes. So tensile properties of the structural steel product. Okay. So this is nothing but the yield stress, ultimate tensile strength. So I have already shown you in this notes the ultimate tensile strength. Okay. So here this ultimate tensile stress for grade number 40, 4.6, 4.8, 5.6, and 5.8, it has been mentioned in this, that is IS code. So here I am referring the IS code, that is page number 13. This is nothing but page number 13 of IS 800 2007. So what this IS code says here, these are the grades of steel. Okay, IS 1367 part 3, IS 1367 part 3. So these are the grades of steel. These are the grades of steel. Okay, 3.6. For the 3.6, what is the ultimate tensile stress? 330. What is the ultimate tensile strength for 4.6? So for 4.6, it is 400. For 4.8, it is 420. For 5.6, it is 500. Okay, for 5.8 it is 520, and 6.8 it is 600. So these I have taken care in this. You have to use this ultimate tensile strength or ultimate tensile stress of bolts, ultimate tensile stress of bolt, from page number 13 of IS 800 2007. That is nothing but FUB. These are the FUB, that is the ultimate tensile stress of a bolts. 3.6 के लिए we have to take 330, 4.6 के लिए 400, 4.8 के लिए 420, 5.6 के लिए 500, 5.8 520, and 6.8 600. We have to take these values from IS code page number 13. Okay, so all these it has been taken care here. Yes, this ultimate and ultimate tensile stress, these are not used, but this will be used in problems. That is this 400, 420, 500, and 520. This it has been mentioned in IS, that is page number 13 of clause. Okay. Next this we will see in as per IS code also. Next is important is this criteria. Okay. Design strength of bolt in shear, bearing, and tensions. I have already discussed. In order to find out the strength of bolt, in order to find out the strength of bolt, or in order to find out the bolt value, we have to first find out the shear strength of bolt. Then we have to find out the bearing strength of bolt. Then we have to find out the tensile strength of bolt. So first we have to find out the shear strength of bolt. Next we have to find out the bearing strength of bolt. Next we have to find out the tensile strength of bolt. So these three things first we have to find out, and the minimum value will be the bolt value. Minimum value will be the bolt value. So how to find out this, or from where, from which page numbers of IS code we have to find out the shear value of bolt, or bearing value of bolt, or tensile strength of bolt. Okay. So we will see from which page numbers we will calculate this, or which page numbers we have to refer this. So in page number 73, all these criteria it has been given. So in page number 73, we will switch over to the page number 73. Yes. So these are the in page number, that is nothing but 75. Okay. So in page number 75, we have to find out the shear value of shear capacity of bolt. Then we have to find out the bearing capacity of bolt. So here there is a bearing capacity of bolt. Yes, bearing capacity of a bolt. And thirdly, we have to find out the tension in bolts. So here tension capacity of bolt is also given. So these three things to be calculate. First, we have to find out in order to calculate the bolt value. In order to calculate the strength of bolt. Okay. So in order to find out the strength of bolt, first we have to find out these three values. So it has already discussed, or it has been stated here. A bolt subjected to factored shear force shall satisfy the conditions, that is VSB that is equals to VDB, V suffix dB, where VDB is the design strength of the bolt taken as the smaller of the value as governed by shear. First, we have to find out the VDSB, that is in clause 10.3.3. First, and bearing capacity, that is VDPB in clause number 10.3.4. The minimum of shear and bearing will be the bolt value. So this it has been mentioned in clause number 10.3.2. So as I have already said that every part of the problem or every designing step it has been mentioned in IS codes. Only you have to refer the proper page numbers, or you have to refer the proper clauses in which clause we have to take the data from which we have to take. So in order to find out the bolt value, or in order to find out the strength of bolt, in order to connect the two plates, so while connecting the two plates with the help of the bolts, so we have to first find out the strength of bolt. In order to find out the strength of bolt or the bolt value, first we have to find out the shear strength of bolt and the bearing capacity of bolt. Shear strength of the bolt and bearing capacity of the bolt. Okay. So here first we will find out the shear strength of bolt, that is given in page number 75 of IS code, that is 800/2007. So what is shear capacity of bolt? Yes, the design step. What is shear capacity of bolt? So shear capacity of bolt it has been given as the design strength of bolt, that is VDSB as governed by the shear capacity of bolt. The design strength of the bolt, that is VDSB as governed shear strength is given by VDSB, that is equals to VNSBV, that is suffix NSB divided by gamma MB. So V suffix NSB divided by gamma MB. Okay. So here VNSB, what is this? A nominal shear capacity of a bolt that has been calculated as given by this VNSB will be calculated from this, that is equals to FU divided by square root of 3 in bracket NN small n suffix n ANB plus NS ASB, NN ANB plus NS ASB. So we will one by one see what is NN, or what is ANB, or what is NS, or what is ASB. These things it has been again given in page number 75. What is FU? FU is nothing but the ultimate tensile strength of a bolt, which has depending upon the grade of bolt. Okay, already I've shown you in page number 13 of IS 800. So this FU stands for ultimate tensile strength of bolt. What is NN? N suffix N, number of shear planes with threaded intercepting the shear planes. Okay, that means the planes which are having the threaded portions. That means number of shear planes with threads. We'll see how many numbers of NN, how to find out this NN. Again, there is a figure in order to find out the NN. So NN is nothing but the number of shear planes with threads. That means threaded portions. Okay. NS is without threads, and S is the number of portions without threads. What is ASB? Nominal plank plane shank area of the bolt. What is ASB? ASB is shank areas. Okay. A and B, it is nothing but the threaded area. ठीक है, A and B is nothing but the threaded area. S stands for shank. Shank is already shown you the figure of bolt. So again we will see again the same figure once again, the bolt figure, and how to find out NN or A and B or NS or ASB. We will see in detail in problems. Okay. So A and B is nothing but the threaded area. ASB is nothing but the shank area. So no need to confuse. All these terms will be it will be solved with in the problems. So when while solving the problems, we will discuss about all these things. Again, if the two members it has been joined with long joints, that means the length of that joint is more. The length of that joint is more. When the length of the joint it is more, when the length of the joint that is L J of a splice or end connection in a compression tension element connecting more than two bolts. That is the distance between the first and last row of bolt in the joint measured in the direction of load transfer exceeds 15D in the direction of flow. That means when this distance exceeds, when the distance of bolt in the that is the connection bolt, when this distance increases 15 times the diameter of 15 times d in the direction of the load, the nominal, that is the shear capacity, it is given in this clause, that is 10.3.2, that is VdB, shall be reduced by the factor, that is beta Lj, given by what is beta Lj. So this beta Lj is the complete formula. That means if it exceeds 15 times d, we have to use this formula. If it is less than 15 times d, then there is no use, there is no need of using this formula. Okay. When it is more than this 15 times d, then at that time we have to use this beta Lj formula. What this D stands for, here also 15D or here also 200D, the nominal diameter of the fastener, that means the diameter of the fastener. When the grip length, that is Lj, that is equals to the total thickness of the connected plates exceeds 5 times the diameters, that is the diameter of the bolt, the shear capacity shall be reduced to the factor of beta Lj. Again beta Lj. So here these are the three reduction factors. First reduction factors, reduction by the factor BLJ. First reduction factors for the length Lj, BLJ, length of the joint Lj. Next reduction factors for the thickness BLJ shall be more than BLG, shall not be more than BLJ. Okay. So what is BLG? It is not again design shear capacity shall be reduced to BLG. We'll see how to find out BLG or how to find out these things. Packing plates, if the packing plates is there, if the packing plate dimension is more than 6 mm, shall be decreased to the factors. The design shear capacity of bolts carrying shear through a packing plates in excess of 6 mm shall be decreased by factor B beta, that is Pk, given by. Again, these are the reduction factors. These are the three reductions factors. Okay. So we will see one by one in problems how to find out these reductions factors or where it has been used. So number one, we are while finding out the volt value, first we have to find out the shear capacity of bolt. Next, we have to find out the bearing capacity of bolt. How to find out the bearing capacity of bolt? Again, there is formula for bearing capacity of bolt. So VNPB, how to calculate this VNPB? There is the nominal bearing strength of a bolt. That is 2.5 times. It is nothing but the 2.5 times KB DTFU. KB DTFU. How to find out this KB DTFU? What is the terms related with this KB GTFU? What is KB stands for? KB is again the fractions, or it is nothing but the fractional factors. KB is smaller of E, that is edge distance. What is E? EDE is nothing but small e is nothing but the end distance. P stands for pitch distance. D0 stands for the diameter of hole. FUB and FU. Okay. So KB is smaller of E divided by 3D D0, 3 times D0. P, that is pitch value, divided by 3D0 minus 0.25, and FUB divided by FY, or 1. So out of these four values, 1, 2, 3 and 4 value, the minimum will be the value for this which has been kept in this formula as KB. Okay. What is the original formula? 2.5 times kb dtfu. How to find out kb? Kb is the values of this 1, 2, and 3 and 4. Out of this 4 value, minimum will be the value as kb. Minimum will be the value as kb. So E is nothing but end distance, P is nothing but the pitch distance, D is nothing but D0 is nothing but diameter of hole, FUB is nothing but the ultimate tensile stress of the bolt. And what is FU? Ultimate tensile stress of the plate. One is nothing but bolt, other is nothing but the plate. So bolt upon plate. Ultimate tensile stress of bolt divided by ultimate tensile stress of plates. So these are the two different terms, plates and bolts. Upper one is the bolt and lower one is the plate. Fu is nothing but the plate. D, what is D? In this formula we are using D, dTFU. So D is nothing but the nominal diameter of the bolt and T is nothing but the thickness. Yes. So these are the terms which has been used in these notes, or these are used in this that is while calculating or while finding out the strength of a bolt. So I am once again switching over to the notes. That is design strength of bolt. We have to find out the design strength of the bolt. So design strength of bolt in shear, bearing and tensions. So design strength of bolt in shear. So this formula I've already shown you in page number that is 75, VDSB VNSB divided by gamma MB, and this formula NN A and B and NS ASB. What is NN or NS, or we are multiplying this complete formula if you divided by with n numbers. So if it is single share is there, that means the number of plates is less, and it is having a single share. So then n is equals to 1 we will take, and when it is double share we will take as n is equals to 2. So this complete formula will be multiplied by 1 or 2. This complete formula here, this is the complete formula. Sorry, this complete formula will be multiplied with 1 or 2. It will be multiplied with this 1 when it is single share, or double share when it is 2. So what is VDSB? So here VDSB formula is VNSB divided by gamma NB. So this VNSB is the complete formula. This upon gamma NB is this. But when we have to use this reduction factors, so beta LJ, beta LG, and beta PK. Okay. So these are the packing plates or gross areas, or when the length of this it is more, when the thickness is packing plates thickness is more, or gauge distance. So these in these three different criterias we are using the reduction factors. Okay. Next. So design strength of bolt in shear, Fu is the ultimate tensile stress of bolt materials. Nn is nothing but number of shear planes. So in this case, this is nothing but the bolt. Okay, this is nothing but the bolt, and this part is nothing but the threaded part. This part, plain part, is nothing but the shank, SHANK, shank. But this part is nothing but the threaded part. Okay, so here this if the planes, shear planes are intersecting at this surface, so NS is nothing but the number of shear planes without intersecting threads. Here this plane there is no threads is there, so NS is 0, where NN is 1. Why? Because there is a one threaded portion. Okay. Again, if it is along this line, so that means there is both NN and NS. If it is above the line, so NN is 0, but NS, uh, this part, that is NN, number of shear planes intersecting with threads, as well as NS is 1. Already this gamma MB, there is partial safety factors for the bolt material. It has been in previous lectures I've shown you from IS 800 2007. We have to take this directly the value of 1.25, that is field welded or bolt, that is the shop welded. We have to take this from IS code 1.25, and the value of gamma MB, that is the partial safety factors. Yes. So these are the reduction factors I've already shown you in the IS code. Reduction factors beta LJ. It is for long joint. beta LG for the large grip and beta PK for the packing plates. Okay. So first, when length is more than 15 times d, अगर length 15 times d से ज़्यादा है, then we are using this beta LG. Okay. When the grip length of grip it is more than 5d, then we are using this formula. When LG is more, it is greater than 5d, then we are using this formula. Packing plate. So when thickness of packing plate is more than 6 mm, so then we are using this formula. When the thickness of packing plate it is more than 6 mm, then we are using the formula. When there is a large grip more than 5d, then we can use this reduction factors. And when length of when there is length of joint is more than 15 times d, then we are using this formula. I've already shown you in page number 75 design strength in bearing per pitch. So these are the design strength. FU of plate, it has been taken as 410. FU of plate, that is the ultimate tensile stress of plate. First, we have to find out the design strength of plate. So FU of plate is 410. That is the ultimate tensile stress of plate. FB in this case is minimum of four values. So minimum of four values. So FB is nothing but minimum of four values. I've shown you in the IS code. P upon 3D0. First one, pitch upon 3D0 minus 0.25. FUB upon FU, or fourth number is, that is 1. Again, tensile strength, we can also find out design tensile strength, which has been mentioned in page number 76. The formula for this is nothing but this. It has been mentioned in page number 76. So while analysis and design problems, so there may be two types of problems. There may be analysis problem also, and there may be a design problem also. So in analysis problem, we have to find out the load. In analysis problem, the different criteria will be given, but we have to find out the load. But in design problem, load will be given, and we have to find out the different that is the sections. In design problem, load will be given. We have to find out the section size and area of that section. But in analysis problem, load it is not given, but bench are given. That means criteria is given. So analysis problem में क्या निकालना है? We have to find out the P. P is nothing but the that is bolt value, as the pitch value is nothing but minimum of these values, shear, bearing and tearing. Shear, bearing and tearing. ठीक है. Whereas design problems में क्या निकालना है? Bolt value में minimum of two, shear and bearing. Shear and bearing. Next, we will switch over to the problems to calculate the strength of 20 mm diameters. What is the diameter of bolt? 20 mm. First, find out the of 20 mm diameter bolt of grade. What is the grade of bolt? 2.6 for lap joint. I have already shown you what is lap joint. So when this plate this is one plate and this is another plate. So these two plates are connected with these two plates so it is connected with help of bolts. Yes. So these two lap joint is nothing but this type. What is butt joint? So this is one plate, this is another plate, and it is connected with a extra cover plate. This is nothing but the butt joint. This is nothing but the lap joint. तो यहाँ पे क्या है? Calculate the strength of 20 mm diameter bolt of grade 4.6 for lap joint. That means joint is lap joint there. So lap joint is there. So that means it has been connected with a joint. This is example of lap joint. What is the size of bolt? 20 mm. What is grade of bolt? 4.6. Depending upon this 4.6, what is the ultimate tensile stress of bolt, which has been mentioned in page number 13. Ultimate tensile stress of bolt, which has been mentioned in page number 13. For LabGen, connecting two plates of 14 mm and 12 mm. That means there are two plates. Suppose this plate is having a size of this plate 14 mm. This plate is having the size of 14 mm, and this plate is having the size of 12 mm. Okay. So these two plates are connected with the help of the bolt, which is having diameter of 20 mm, grade of 4.6. We have to find out whether it is safe or what is the strength of bolt. Whether this 20 mm size of bolt is sufficient to join the two plates. Whether this 20 mm size of bolt is sufficient to join the two plates. So here, yes, the strength of one bolt, that is equals to minimum of two values. So minimum of two values. So VDSB, again this formula, it has been mentioned in AS code. This complete formula from this part to this part, this complete formula, it has been mentioned in AS code. Only we are multiplying with the n. N stands for the number of shear planes. That means whether that shear plane in this threaded portion, it is overlapping with the threaded portions, or it is overlapping with the shank portion. SHANK. Shank is the plane, that is bolt. Shank is nothing but the plain bolt. Whereas threaded portion is the where threads are provided. Here, suppose there is a bolt figure. I am drawing this as a bolt figure. So here these are the threads provided in bolts. अगर ये threads रहते हैं ऐसे, and these are the plain surface, and there is a head provided here. This is bolt. Okay. So this is nothing but the shank area. There is nothing but the shank area. Okay. Whereas this is nothing but the threaded area of the bolt. So this is nothing but the threaded area. This part is nothing but the threaded area. So VDSB, that is multiplied by n. This formula, it has been mentioned in IS codes. So here we are assuming that number of shear planes in this case is, we are assuming this, there is the area of A and B, that is A and B and ASB. Okay. What is the formula? It has been given in IS code. Here this formula, it has been given in IS code. This formula, yeah. VNSB is equals to FU divided by square root of 3 NN A and B plus NS ASB. NN A and B and NS ASB. Okay, this formula that has been used to find out the shear capacity of both. Okay, FU divided by square root of 3 NN A and B and NS ASB. What is NN? Number of shear planes with threads. That means threaded area. So we are considering there is no threading area. Only the bolt that has been tightened on along the shank area, this area. That means A and B and this NN is 0. Okay. So or this part is 0. Sorry, this part we are assuming this part as 0. NS and ASB. That means there is no shank area. We are tightening the bolt in threaded area. This area, threaded area. So this shank AS, NS and ASB, we are considering this as 0. Okay. Yeah, always in every problem, this we can assume this NS and ASB as 0. That means the whole bolted area we are considering as the this area. Okay, we are not considering in the shank area. We are considering it in the threaded area. The same way we have taken this formula. Okay, so this is nothing but ASB. Sorry, A and B and ASB. Here there is S. How to find out the that is shank area and the threaded area? The threaded area is nothing but 0.78 times the shank area. Okay, shank area is nothing but the plane area. This is plane area. That means this area will be full. But this threaded area, some area will be reduced. So how much area will be reduced? So it has been given in this formula. That is area of that is A and B. That is equals to that is the threaded area is equals to A and B is nothing but the threaded area. That is approximately equal to 0.78 times the shank area. That is pi by 4 d square. That is diameter of bolt. Here number of shear planes we can take as 1 or 2. So again BD PB that is given as 2.5 times KB DT FU upon gamma and B. So we will start first the problem. First we have to find out the strength of bolt value, that is this. What is the diameter of bolt? So diameter of bolt is 20 mm. What is diameter of hole? So we have to take extra as factor of safety of 2, which is again mentioned in IS codes. So in IS code again this factor of safety it has been given. Okay? So in IS code this factor of safety it has been given here. Here. Clearance for the fastener of holes. It has been mentioned in 73 page numbers. Okay. If the nominal size of fastener D it is 12 to 14 mm, then standard clearance in diameter and width of slot. That means extra we have to take oversized clearance in diameters. So here, if it the diameter of bolt is 16 to 22, now we are using the diameter of bolt as 20. That means it is in the range of 16 to 22. What is the extra clearance we have to take? That is 2. This 2, we have to take extra clearance for this diameter 16 to 22. We have to take this as 2. So here we have taken this as 2. Yes. The diameter of hole is equals to 2 plus diameter of bolt. So 2 plus diameter of bolt diameter is 20. So 2 plus 20, that is 22. Why we have taken this 2? So it has been taken from page number 73 of IS code. So extra there is for bolts, that is the extra area required for tightening the bolts in the plates. So that is 2 plus diameter of bolt, that is 22. For grade number 4.6, what is FUV? So FUV, it is again mentioned in this table. I've already shown you in page number 13. So FUV 4.6 के लिए FUV is nothing but 400 Newton per mm square. FYB it is 240. FU it is 410. This FU you have to always keep in mind the value of this FU as 410 Newton per mm square, whereas FUB is 400 Newton per mm square, which has been mentioned as per the IS code, that is grade of steel 4.6. So there are the two plates. 14 mm one plate is there, 12 mm other plate is there. One bolt of 20 mm size of bolt it has been attached. So area of shank portion pi by 4 d square, d diameter of bolt square, pi by 4 diameter of bolt square, 20 square. So it comes to be 314.16 mm square. A and B, that is the area of threaded portion, it is 0.78 times area of shank portion. So because threaded portion it is having less area, here it is 78% of 0.78 is nothing but 78%. 78% of shank area. 78% of shank area. So 0.78 ASB, this comes to be 245.04 mm square. Next, what is design strength of bolt? I've already said you the shank area is 0. We can take the shank area directly at 0. And we are considering this two planes as the single shear. If the number of plates is more, so we can take this as two numbers also. Here we are taking multiplying this n with 1 y because it is single shear. Okay? The complete formula we have taken, but here instead of this plus ns ASB, we have taken this ns ASB 0y, because we are assuming it in the we are this in this part we are assuming this part as 0y, because we are assuming only the threaded portions. Okay, we have taken this part only threaded portions. So simple values are FUB, we have to directly fill in the values of 400 divided by square root of 3. 1.25 it has been gamma MB. That is the partial safety factor. Again, it has to be taken from the IS code. This 1.25 it is taken from IS code. Okay, it has been taken from IS code. Again one, only one shear plane we are considering, and a there is area of threaded portions 245.04 threaded portions we have calculated. 10 to the power minus 3 by we have taken because we are converting this into kilonewtons. If we are not multiplying with 10 to the power minus 3, then it comes to be some larger there is digits it comes to be. So we are converting this into kilonewton, therefore we are multiplying with 10 raised to minus 3. 45.25 kilonewtons. It comes to be 45.25 kilonewton. The design strength of bolt in shears. So in shear, the values comes to be 45.27 kilonewtons. Yes, N is not considered when double shear is given. Next is design bearing strength. How to find out design bearing strength? VDPB, that is formula is again 2.5 kb DGFU. It has been taken in IS code from page number 75. It has been taken from the page number 75. KB is smaller of four values. It has been mentioned. What are these four values? H distance divided by 3d0, pitch 3d0 minus 0.25, 1, and last is FU, BF1, FU, and 1. So these are the three values. How to find out E? E minimum is 1.5 times D0. It comes to be 33. We are taking as 40. So what is the minimum pitch value? Minimum H distance as per IS code? 1.5 times D0. 1.5 times D0. E minimum is 1.5 times D0. D0 is nothing but the diameter of hole. The original diameter of bolt was 20. Diameter of hole is 20 plus 2, that is 22. Here it is diameter of hole. What is minimum pitch value? 2.5 times diameter of bolt. 2.5 times diameter of bolt, 50. We can take this as approximately 60. Here 33 was there. We have taken approximately as 40. This is deciding problem, so we can take approximate values also. E, E that is 40 divided by 3 times diameter of hole, 22. It comes to be 0.606. Pitch upon 3d0 minus 2.5. The pitch here we have taken as this 60 divided by 3 into 22 minus 2.5. It comes to be 0.659. Here it is 0.606659. FUV 400, that is ultimate tensile strength of plate and ultimate tensile strength of bolt. The upper one is plate, the lower one is bolt. So in plate, always we have taken this as 400, whereas bolt we will take from the grade of 4.6. What 4.6 grade of steel, bolt? It comes to be 410 as per the table. So it is 0.97 and 1. So out of this 1, 2, 3, 4. So which one is minimum? The minimum value is this value. This value is minimum value. See? So out of these four values, which one is minimum value? So this is nothing but the minimum values. That is 0.659 or 606 or 659. One and the same. The KB value, take the value of this KB in this formula as 606. In this 2.5606, diameter of the bolt, that is 20. Thickness of plate, that is we have to take the minimum thickness. Out of 12 and 14 we have taken this as thickness of plate as 12. FU is given 410 and gamma MB, that is 1.25. 410, 1.25. It comes to be 119. So in previous we have calculated it as 45. In this case 119. What is the minimum value? 45. The bolt value is minimum of two value, that is shear and bearings. Minimum of two, that means shear and bearing. So out of this shear and bearing, what is the minimum value? Out of this shear and bearing, what is the minimum value? The minimum value is 45.25. So 119 and 0.26 and 45. The bolt value is nothing but 45.25. So in this way, we have calculated the bolt value. In this case, we have calculated the bolt value. Okay? So we are, while calculating the bolt value, we have to keep in mind the two things to be calculated: shear value of bolt and the bearing capacity of bolt. Shear value of shear capacity of bolt and the bearing capacity of bolt. Okay. So in next lectures again we will see some more problems related with the bolt value. How to find out the bolt value? As I've already said, every part of the formula or every step of the designing step, it has been mentioned in as code. Only you have to find out the page numbers and we have to take properly the data which has been given in the IS course. Okay. So if anyone having any queries or any problem, they can ask. Okay. Here in today's lectures, we will end this today's lectures regarding the design of bolts. Okay. That is the bolt value. So thank you everyone. Thank you.